Hey, I'm going to be looking at 2017 number 5, part B. In part A, you're going to be taking the derivative, and I would switch this to taking the denominator, put it in parentheses, raise it to the -1, and do that derivative. And then you end up here with this derivative, and it's asking for the x-coordinate of each critical point on the interval from 1 to 2.5. And that's pretty interesting, that interval, because if you look at this 2x squared minus 7x plus 5, that's squared, it is factorable. So you can, out of that, get like a 2x and an x. 5 is going to be 1 and 5. I don't want the 2 multiplied by the 5 because that'd be 10. So I'm going to put the 1 over here and the 5 over there. And with that negative in the middle, but the plus there, these are both subtractions. So we do have what makes the denominator 0 would be x is 1 and x is 2.5. So it's interesting when they ask for the critical points that are between 1 and 2.5, it doesn't include those. So we're not looking at the undefined, but remember undefined does give the possibility of a critical point when the derivative is undefined. So we're really only looking at the numerator being 0. So let's see if that ends up working. 4x minus 7 equals 0. So 4x is 7 and x is 7/4, which is a little bit less than 2, which is actually between 1 and 2.5. So there's our awesome little critical number. That's the x-coordinate that's between 1 and 2.5, not inclusive. That has a critical number there for f. And then it's asking to classify as a relative max, relative min, or neither. So let's do our little line test. I'm going to be testing in f prime. We have 7/4 here. So to the left, maybe I'll plug in. And remember, it's between 1 and 2.5. So maybe I'll plug in, gosh, what should I plug in? Something bigger than 1? How about 1.1? Ha-ha! Okay, if I plug in 1.1 over here, we've got a negative times a negative, which makes that a positive. And to the right of 7/4, maybe I'll plug in 2. If I plug in 2, we've got here 8 minus 7, which is positive 1. Negative times a positive, that's a negative. And I'm really only looking at the numerator here because the denominator is squared. It is always positive. It's not changing the sign there. And that's another reason why, even though these two make the denominator undefined, they're not going to cause a sign change because each of those ends up squared. The denominator is not causing any sign change. Okay, so we have increasing to decreasing, or the derivative positive to negative. That is a local max. However, AP does not accept this as your justification. So let's write our sentence. I can say f of x has a local max at x equals 7/4 because I can say f of x is increasing on from 1 to 7/4 and decreasing from 7/4 to, what was our cutoff here was 2.5. So we can say that. You could say that it's increasing directly to the left of x is 7/4 and decreasing directly after 7/4. You need to mention that it is f of x that's increasing and decreasing. You need to mention the x of 7/4. And you could, instead of saying f is increasing, you could say f prime is positive, and you could say f prime is negative. So there's some different ways to say it, but you do actually have to write a sentence. This is not enough for a justification. Enjoy!